Oh, hey, how you doing today? Today we're going to be talking about thermometers and temperature. And a couple things that I need you to know is, first of all, what is temperature? Well, when we think of temperature, we think about, well, how hot or cold it is outside or something like that. And in science, temperature is actually a lot more precise than that, and there's a little bit more specific detail to it. So temperature in science is the measure of the average kinetic energy of the particles in an object. So all objects are made up of particles, like atoms, okay? And so let's say we have a glass of water, and we want to measure the temperature. Well, what we're actually measuring is how fast are the water particles moving around in the cup. And even though we can't see it, the atoms and particles are moving around. We just can't see it. It's happening at such a small level. Well, what happens then to take temperature is this red bulb, you put it in the glass of water, and depending on how warm the water is, the particles of water are going to pound into this red bulb. And they're going to transfer their kinetic energy, their motion energy, into the liquid inside of here. The hotter the water is, the more the particles are going to move, the faster they move, and they're going to hit this bulb harder, causing the red liquid inside here particles to move faster. And what happens when particles start to move faster is they need more space. Because if they're moving slow, they can work on a little area, but when they move faster, they start spreading out more. Okay? And this thermometer only has a thin little tube where the liquid can go in. So the faster those particles inside are moving, the more it wants to expand. But the only way it can go is up, therefore raising the temperature of the on the thermometer. Okay, so that red line is going up to a higher temperature. So the hotter the particles are, the water is, the faster the particles are moving, the more they transfer energy to the red liquid in the thermometer, causing it to expand and go higher. Now the opposite is true as well. So if the water is getting colder, the particles of water are slowing down. They're not going to pound on this red thing as hard, so the liquid in here, the particles are going to slow down. They don't need as much space because they're moving slower, so they start to come together and they start to cause the temperature to drop, or the liquid tries to go down, causing the temperature reading to be lower. So that's basics of how a thermometer works in a nutshell. Okay, so again, a thermometer, in temperature, we're measuring the average kinetic energy of the particles in an object. Okay, now we have different temperature scales. The main one that we use in the United States is the Fahrenheit scale. On the Fahrenheit scale, water boils at 212 degrees. It freezes at 32 degrees. There's another scale that's more common in the world. We don't use it here very often, but in the world it's very common. It's the Celsius scale. Water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. So 0 degrees Celsius and 32 degrees Fahrenheit are actually the same temperature, just two different scales. The same with 212 degrees Fahrenheit and 100 degrees Celsius. Same temperature, just different scales. There's a third scale that's used mostly in science, and that's called the Kelvin scale. And really the biggest thing you need to know about Kelvin is absolute zero, which is 0 Kelvin. That is the temperature at which all particle motion stops. That's the coldest temperature that can ever occur. Things can't get colder than 0 Kelvin because the particles stop moving at 0 Kelvin. And technically that doesn't happen. In science labs you might be able to make it happen, but it doesn't happen in nature. Objects, even when water is frozen, the particles are moving in that water. Just a little bit, but they're still moving. Okay? So hopefully that gives you a good idea of how a thermometer works, what temperature is, the different temperature scales, thermal expansion, which is how the process works. And again, I'll just quickly review that. Thermal expansion is when objects warm up, the particles that are in that object start to move faster, and they need more space so that each individual particle spreads out, causing the entire thing to increase its volume or its size. A good example of this in the opposite direction really is if you ever leave a basketball outside overnight on a cold night, when you get up in the morning and you go out there, the basketball is like flat or partially flat. That's because the particles in the basketball during the day before were moving around fast enough to keep the ball inflated. But when they got colder, they started to slow down and they contracted. They didn't need as much space, so the ball became flat. Alright, hopefully that's a good explanation for you and you understand a little bit better what temperature is, how thermometers work, and thermal expansion, and how the kinetic energy, which is motion, is related to that. If you have any questions, please make sure you see me. I'll be glad to help you out and we can get through this and have you understanding this stuff in no time. Have a great day.